Dependency management is complex and often a frustrating part of software development. Are you also worried about how to manage different plugins and dependencies efficiently? Hi, I'm Sritej, Customer Success Technical Consultant here at MuleSoft. In this mini course, we will show you an efficient way to manage dependencies for MuleSoft applications. Let's get started. At the end of this mini course, you will be able to efficiently manage Mule dependencies in poly repository model and develop a simple build pipeline for Mule applications using Maven, Jenkins and GitHub. For the sake of simplicity, consider a scenario where an e-commerce organization is launching new mobile application to provide online shopping experience to its customers. Multiple development teams, order fulfillment, and payment services teams are building integrations and APIs required to support end-to-end solution. This requires designing consumer-focused API specifications and connecting multiple internal and third-party systems while also working with the central IT. To realize this, a set of APIs and integrations are being developed using MuleSoft, aligning to API-led methodology. Each team is working at its own pace. One of the major pain points that every team faces is to effectively manage dependencies in Mule applications. An organizational IT leadership typically sets the standards that must be met. As per the compliance and governance standards, each team must only use central IT approved dependencies, Mule Maven plugins, and their associated versions. Each team is also responsible for reducing the redundancy as much as possible, which includes to make use of existing functionality wherever possible, also making use of the standard and enterprise logging and exception handling frameworks which are already available in the corporate Nexus repository as Mule modules. Other examples also include common Mule flows, reusable data view modules, etc. Also, each team must make use of the common health check endpoint implementation in every Mule app. This is also packaged as a Mule module and published to Nexus repository. Each team must adhere to corporate governance standards such as Git repository organization and branching strategies, which is poly repository model in this case. As we understand the current scenario and the organization structure, we assume the following: that each team is responsible for building a specific set of APIs and Mule applications while also maintaining their source code in Git repositories. Each team decides the plugins they want to use, while the central IT dictates the versions of commonly used modules and plugins. To get started with the course, the following technology setup is required. During this course, we'll be using GitHub as a source control, Jenkins to automate deployments, Nexus as a repository manager, Maven as a build tool, Anypoint Studio for the app development. We assume you already have these tools installed and set up. As we understand the standards set by the central IT team, let's start implementing Salesforce System API that returns the list of orders placed by a customer. Assuming that you already have the API spec designed and published into the Exchange, let's start implementing the actual project using the Anypoint Studio. From Studio 7 or later, all Mule projects are Mavenized and a POM file is created automatically when a project is created. Let's take a closer look at the POM file. All the common modules like the Mule Maven plugin for build process, Mule HTTP connector for HTTP communication, Mule API Kit module for the API Kit router are automatically added. Also, when new modules are added to the project, their associated dependencies along with their versions are added into the POM file. For example, let's add Mule Secure Properties Provider into the project. Once the module is successfully added into the project, its associated dependency along with its version is automatically added into the POM file. As the projects start to scale and new projects start coming in, all the common dependencies and its versions are duplicated. So let's create a new project order process API. that orchestrates the order placing process. As you take a closer look at the POM file in the order process API, all the common modules like the Mule Maven plugin, Mule HTTP connector, order process API ramel, Mule API kit module, and its associated versions are added automatically into the project. So as the number of projects start to scale, it leads to a lot of redundancy in managing dependencies or plugins in every project, conflicting versions management. Also, as new versions of the modules are released, the dependencies are not updated automatically in old projects. So they continue to use old versions while the new projects start using new versions. Let's move further into the course to understand how we can reduce these redundancies. Implementing a scalable approach is essential in order to drive adoption and improve operational efficiency in your organization. In order to reduce redundancies and minimize the conflicting versions, the best practice approach for this is to extract Maven build configuration that are not specific to the Mule app from pom.xml into a reusable parent POM called parent pom.xml. As a result, each project's pom.xml is further reduced in file size, which overcomes the challenges arising due to versions conflict and provides a centralized place to dependencies, plugins, and repository management. Also, it provides an additional benefit to streamline the dependencies upgrade process. For example, Central IT can monitor releases of a HTTP module and test the latest release if it works well connecting to your internal systems, while also making sure the same version of the module is used across the board as a standard. In a typical organization, version management and plugin management change on different timescales. For example, it is more common to update the versions of dependencies or endpoint connectors than it is to change the configuration of plugins. So dependency management can be extracted into their own special kind of parent POM called Bill of Materials, in short BOM. This BOM focuses exclusively on managing dependency versions, irrespective of other details of Maven build, such as what plugins are executed with each configuration. Organizations can use BOM mechanism to centralize and communicate dependency versions that are known to work together because they may have gone centralized integration testing, or may have been vetted by the security team, or may have been provided for general use in the corporate artifact repository. So employing this approach, app team could manage the parent POM to standardize the usage of plugins, and Central IT could manage BOM to standardize the dependency version management. Let's get started with building the parent POM file and BOM file. On the left hand side of the screen, I have two POM file templates open, one for the parent POM, the other for the BOM file. On the right hand side of the screen, I have the applications POM open. First, let's get started creating the parent POM file and extract all the reusable configurations. Then we can move forward to build the BOM file. Firstly, I'm moving all the common properties, build plugins and dependencies into the parent POM file. We can also manage the repositories and plugin repositories from the parent POM file, but in order to keep this tutorial simple, I'm sticking to properties, dependencies and build plugins. Next, I'm adding distribution management into the parent POM file. This is required to publish the built artifact into the artifactory, which is Nexus in our case. Next, I'm updating all the versions of the build plugins and dependencies to be as properties instead of hard coding them. If you also observe, I added two new tags, plugin management to enclose all the plugins and dependency management to enclose all the dependencies. These are required as per the Maven standards. Next, let's add all the properties of the build plugins and dependencies into the properties section. This helps to clean the POM a lot. If you observe from now, the Mule HTTP connector version will be retrieved from the property listed above in the properties section. Now that we extracted all the reusable items out of the application's POM, let's move forward to build the BOM file. To get started with building the BOM file, first we need to move the plugin management, dependency management, distribution management, and their associated properties from the parent BOM file into the BOM file. Remove the properties or items that are not required to be in the BOM file. Save the changes. Moving back to the parent BOM, remove the configurations that you moved into the BOM file. Next, in order to inherit the configurations from the BOM file, add a parent tag for the BOM file. This parent tag has the group ID, artifact ID, and version of the BOM file, which are required to retrieve the BOM file from the Nexus repository during the build process. Next, as we discussed earlier, that the order fulfillment team wants to use Cloud Hub for their deployments, they can make all the required Mule Maven plugin Cloud Hub deployment configuration in the parent POM itself, as this parent POM will be exclusively consumed and maintained by the order fulfillment team, thereby reducing the duplication of Cloud Hub deployment configuration in Mule Maven plugin across all the order fulfillment team applications. Once you make all these changes, save both the files and publish them to the Git repository. So now I push the BOM file and the parent BOM file into the GitHub repository. Now let's go to the Jenkins dashboard and create simple pipelines for the BOM file and the parent BOM file. Let's get started with the BOM demo. Here is the simple pipeline for the BOM file. First, I configured the GitHub repository. No credentials are required as this is a public repository. I configured the build schedule. Then I configured the Maven command that needs to be executed from the shell to successfully publish the BOM file into the Nexus repository. Then I configured the root BOM file. Then hit save and trigger the build manually. Go to the build and observe the console output. Now the build is success, and go to your Nexus repository and view if the artifact is published successfully. Here you can see the BOM file has been successfully published to the Nexus repository. Similarly, build a simple pipeline for the parent BOM file. So similarly, I created a simple build pipeline for the parent POM, configured the GitHub repository, configured the build schedule, configured the same Maven command that needs to be executed from the shell to successfully publish it to the Nexus repository, configured the root POM file, now it's the parent POM file, hit save and trigger the build manually. Now we see the build is success, and move to Nexus to verify if the parent POM file has been published to it successfully. Now as you see, you can see the BOM file and parent POM file has been published successfully. Now let's go to the Anypoint Studio and configure our Mule app to inherit this parent POM file. Before we make any changes to the POM in the Salesforce System API, let's configure our local Nexus repository username and password, Exchange repository username and password in the server sections in the local Maven settings file. Next, configure the respective repositories in the currently active profile in the local settings file. The Exchange repository is used to retrieve the API spec that we just used during the build process. Similarly, the local Nexus repository will be used to retrieve the parent POM and BOM file during the build process. Once you finish the changes, let's move on to the Anypoint Studio and make some configurations here. In order to ensure consistency in the application development and the build process, let's configure our Anypoint Studio to use a local Maven configuration. In order to do that, go to Anypoint Studio, Preferences, and check the Use Embedded Maven Installation flag. Configure the local Maven installation path. Click the Override Settings Security path. Configure the local Maven settings file path. Click Test Maven Configuration. Once it is success, hit Apply and close. Next, move on to the POM file in your Salesforce System API. Add the parent POM dependency, and now let's remove all the versions in the POM file. Here I'm not removing the version for the Salesforce System API YAML because this dependency is exclusively for this application and it won't be reused across other applications. Once you remove all the versions, hit save and publish this to the Git repository. Once you publish it, move on to the Jenkins dashboard and let's build a simple build pipeline for the Salesforce System API. In your Jenkins dashboard, click the new item, select the type of the project. In the configuration page, select this as a GitHub project, provide the GitHub URL. In the source management section, select it as a Git and provide the GitHub URL. Provide the branch specifier, configure your build triggers, provide the Maven command, provide the pom.xml path and hit save. Let's initiate a build manually. Once a build is initiated, go on to see the console output of this particular build. If you observe the logs, this particular build is being built using Mule Maven plugin with version 3.4.1. If you go back and see your POM, we haven't specified any Mule Maven plugin version, but this Mule Maven plugin version is being retrieved from the POM file. Hope this tutorial will serve you as a starting point to streamline your dependency management process. Thank you for watching this mini course. Please feel free to comment. Also check out the links in the description for more information. Look forward to see you in the next mini course. Thank you.